manufacturing, advanced materials and additive technologies. So today the day 2, session 4, the expert is Dr. Vinod Kumar, Associate Professor, Department of Mechanical Engineering, RMK Engineering College, Chennai. So today's session topic is digital twins and smart manufacturing ecosystem. So it's my honor to introduce our chief guest, Dr. K. Vinod Kumar, Associate Professor, Department of Mechanical Engineering, RMK Engineering College. So Dr. Vinod Kumar holds BE Mechanical Engineering and M.Tech from Pondicherry University and a PhD in Polymer Composite from Anna University. He is currently pursuing M.Tech in Artificial Intelligence and Data Science. He has received Best Faculty Award and Best Mentor Award from the Institution of Engineering. With over 16 years of teaching and research experience, he has published more than 30 research articles indexed in SCI and Scopus. He also serves as a reviewer for various SCI indexed journals. Dr. Vinod Kumar has published over 10 patents with 3 patents granted, demonstrating his strong contributions to innovation and applied research. So, on behalf of the Department of Mechanical Engineering, Weltech Multitech, Dr. Rangarajan, Dr. Soundala Engineering College, I extend our heartfelt welcome to Dr. K. Vinod Kumar, RMK Engineering College. So, we are truly grateful for your gracious presence and for sparing valuable time to share your knowledge and experience with us. So, once again, I would like to welcome Dr. Vinod Kumar K, Associate Professor, Department of Mechanical Engineering, RMK Engineering College. Welcome you, sir. Now the session is yours, sir.
Okay, thank you. Thanks for your wonderful welcome. I hope my voice is audible, right? Are you able to hear me? Anyone can answer me? Okay, fine. So I will start my speech formally. So today I am going to deliver one of the interesting topics.
Please share your presentation, sir.
No, 1 minute.
Yes, sir.
I hope my screen is visible, right? My screen is visible?
Yes, sir, visible, sir.
Okay, fine. Good. Thank you. So, first of all, good afternoon to everyone. It's my pleasure to be here, going to give talk on digital twins and smart manufacturing. So, first of all, I would thank the management of Weltech and Multitech, principal and the head of the Department of Mechanical Engineering and the organizer, and the warm welcome given by the Sivaram sir. Everyone I will thank. So it's my great pleasure. So, and then once again I thank for the participants for giving me this opportunity to speak on the exacting and rapid evolving topic, that is digital twins and smart manufacturing ecosystem. So already there is given brief introduction about me. So today I will be sharing the insights in how digital technologies are transforming the modern manufacturing. We are living in the era where industries becomes smarter, faster and more connected than ever before. I hope you all agree with my point. But the technologies such as artificial intelligence, the Internet of Things, cloud computing, and the big data analytics are reshaping the way of the product designed and manufactured and maintained. So first and foremost, maximum I believe that the maximum of the participants are mechanical engineering background. So we are thinking that our job is only design something, manufacturing something. So our salary may be around maximum 1 lakh per month or 60,000. Most of them in Chennai based tier 2 institutions are joined in the some of the companies which is very less salaries because they are saying that mechanical will not give that much of salary, right? So, but I can proudly say that our students are earning more than 24 CTC, 45 CTC per annum within a short durations, within a 2 years or 3 years. So in that 2 years, how they are earning, even though we are in a 16 years or 20 years of experience teaching faculty, our CTC is not more than 15 or 20 in as a associate level. If it is a professor, it will go on 24. That's all. That also, if you get professor, it's more than 20 years of experience. But in short time, our students are learning more. That is one of the highlight knowledge they having is digital twin. Like that, the terms are may catchy, but we can proudly say that in 2014 itself we started the ELM based. So before going enter into the art title, among the this innovations, the digital twin technologies has emerged as one of the most powerful tools of Industry 4.0. It allows the industries to create the virtual replica. You should know that it is a virtual replica of physical machines and the systems, monitor the performance in real time, predict the failures. That is the most important. Predict the failures before they occur and optimize operations for better efficiency and productivity. Because all the companies will run under the mostly with an a high efficiency and high productivity. You may be all cross with the Six Sigma concept or Japanese tool. More number of tools are for made for only for the reducing or increasing the production costs and reducing the losses. Okay. So imagine that a factory where the machines can tell the engineer, you should understand that. Imagine a factory where machine can tell engineers when they need maintenance, when they need production lines automatically to adjust, change demand, and the managers can monitor the entire plant from anywhere in the world. You should imagine that one. Okay, that is the most interesting. Now the tier one or OEM industries are using this much of the technologies are nowadays, because everywhere in around the world they are moving here and there. So within a we cannot able to open the plant everywhere and go there. Okay, so India is the most automobile hub, whether you know or not. That is India is the one of the foremost hub. They are having We are having the more production plants in India. Okay, so but if you see here, so imagine the factory where the machines can tell the engineers when they need maintenance, when they need a production line to change automatically, adjust the demands, and manager can monitor the entire plant from anywhere in the world. So this is a no a longer vision of the future. It is already becoming in a reality through two things. One is digital twins and another one is called as smart manufacturing systems. So during the sections, we will explore some of the areas. So what I can able to say this is what is digital twin, how they are work, and what are the concept of smart manufacturing ecosystems. What is the technology behind this innovation? Their application across the different industries and the benefits and the challenges and of implementation. What is the future trends and the opportunities in intelligent manufacturing? But at the end of this presentation, I hope you will have some understanding of why digital twins are considered one of the key drivers of the next industrial revolution. Understand that next industrial revolution. So, without a further delay, Let us begin our journey with an fascinating world of digital twins and smart manufacturing ecosystems. So, have you wondered if a machine could predict its own failure before it actually breaks down? Or if suppose if an entire factory could be monitored and optimized without of physically being there, that is exactly what digital twin technologies makes possible. And today we will explore how it's revolutionary manufacturing. So this is the most interesting area in that. So I hope you all see that it is one of the wind turbine. Wind turbine is very difficult to maintain and service, and at the time if you see that how it managed. But the digital twin will play the major role to nowadays is monitoring the systems because renewable energies are play the vital role due to the very high usage of electronic components. So we need more number of energies are required. So in this, so manufacturing is evolved a lot of things. So first of all, very dramatical and a very clear concept. What is digital twin? Digital twin is nothing but a real-time digital replica of a physical asset, process, or system continuously synchronized through sensor data and analytics. That is the first purpose. When embedded within a smart manufacturing ecosystem, digital twin interfaces with respect to IoT, AI, and cyber physical systems to drive the Industry 4.0 transformation. So here in our RMK we have a number of COEs. Totally we have 17 COEs. Whatever we listed here, IoT, AI, cyber physical systems. In mechanical, we have PLM. In civil, they have GIS, and in triple department, they have embedded systems. So, like that, our department will integrated with each and every center of excellence. Specifically, the very huge strength in CAC that is divided into 60-60. 160 students will belongs to one COE, Center of Excellence. COE is nothing but Center of Excellence. In CSE, they have more number of Center of Excellence. And with respect to EC also, they are also having more number of Center of Excellence. Because we, initially, we have only one name, mechanical engineering means mechanical engineering. EC means ECC. Now they are asking, due to the industrial revolution, they are asking a specific outcome of the students. Early and all, company will take the students and recruit the students. They will may give the training for the students and then they will do the process. After that, furtherly, they will some of the trainers will come to the college and they will train the students and then they will pick the very prominent student. Now, what industry is current trend? As a I am a VLM Spark. So when I getting some information from the industry, they are not ready to give training. They are not ready to give any sort of what is happening here, what will be required. They recruit the students daily in a day one itself, deploy in the bench. That is the expectation. So in the because so that our management is given the center of excellence to various department. For that we created some of the infrastructure for that because it's a money involvement. So all the courses will be have different skills. Okay, so mainly we have digital twin is physical world, digital world. Physical world is nothing but machines, product, processes. Digital world is nothing but models, simulation, and analytics. So digital world is I replicated in the animation point of view. So this is one of the wind turbine, how it's working, how animatedly it is doing in a Japanese based company. So live example, if we take Google is the one of the live example. Physical road is there. Traffic sensors are there. Or cameras or loop, GPS, IoT devices are connected to the cloud. cloud will give the live navigation. So this is the best example of digital because day to day in Chennai based areas we are using a Google Map mostly. Most of them we using the Google Maps. So how the digital twin will converting is like this. So as a mechanical engineering point of view, when we have the motor or any pump, so it is connected with the vibration sensor, temperature, current sensors, or pressure and flow or acoustic, whatever it may be built. That sensor will give data to the cloud. Cloud will be changed into digital twin, that is virtual mode of simulation of health monitoring and anomaly detection. What will give? Why we need our digital twin? What it will give us? Maintenance decision in point of maintenance plan. Okay, condition assessment diagnosis and the protective maintenance scheduling, maintenance actions and work order, performance improvement and cost optimization. So this is the main use. Okay, digital twin is a dynamic virtual representation of physical object and machine production line or factory continuously receiving the real-time data for sensor and IoTs. I hope you all know that what is the abbreviation of IoT. Okay, and again I'm saying that don't think that artificial intelligence is made for only the computer science department. They are nothing will do without data. Without data. Okay. So what data they can do? So that data will be given by like our core department sector. Okay, mechanical like people or civil or whether they will give we can because we only have a more application point of the thing. So from that they derive the data. So that data is given that more what is the category. If you think that if you're having a bearing systems or brake pad, when continuously we give some data. Okay, because I'm working in AI area, I'm doing my MTech in SRM for 1 year I completed, still 1 year more than. So definitely we will complete successfully. So it is very interesting area because we will totally I'm having 16 years of mechanical and from 2005 onwards I'm in mechanical domain. After that suddenly I'm going into the AI will give that what is Python, how we learn of Python. We are studying about the big data. We are studying about the deep learning process. What is LLM? Other things and all we are doing. Okay. So here you can see that the two best example in our real-time application where the digital twin will be used. Unlike that, it is a static model or offline simulation. Digital twin is well the physical asset throughout the life cycle. Physical asset that is the most important. Okay. So what are the main characteristics? Real-time synchronization and bi-directional communication. I hope you know that what is a bi-directional communication. And then continuous monitoring and protective analytics. And finally, AI-enabled decision support. Okay, everyone nowadays is using code and other things are using. So like this, we are having the support. Then what are the major components of digital twin? When we saying about the major component of digital twin, so first physical asset, data connection, and virtual mode and analytics of AI. This is the four important parameters in that content. Okay. So here when we speak about this one, when before going to this, we should know about what are the smart manufacturing ecosystems. Digital twin is not operated by isolation. They are embedded with a broader connected ecosystems that enables the real-time decision making across the entire value chain. So you maybe see that we have five different ecosystems. One is called as initially first one is called as ERP. I hope whether when the students will have more idea about ERP, they can recruit it. Still, there are more number of opportunities in the ERP area. And then second one is we can speak about the supply chain management. Third one is PLM, and fourth one is MES. MES is nothing but manufacturing execution system, and finally IIoT systems. What is IoT system? Is industrial Internet of Things. So these are the major area in smart manufacturing ecosystems are works. Okay, you may be aware about how it is working. So in that smart manufacturing system, how smart manufacturing systems are working? Smart manufacturing integrate with the multiple technologies into connected ecosystem. The main building block included one is called as IoT. It connected the machines with various area, and the second one is called as nowadays we are using as a makes artificial intelligence also one of the ecosystem. It makes a intelligent decision to give that, and the second one is big data analytics. It is nothing but it is a process of million of data points. And finally, we have cloud computing. Cloud computing is a provide a scalable computing resources and auto robotics. Nowadays, we are using more number of auto robotics oriented. That is called as automated production. And then autonomous vehicle moves materials to automatically, and augmented reality. That is AR VR is helps the technician during the maintenance. And finally, now the digital threats are more, so they're implementing the cyber security to protect the manufacturing system. And finally, we have edge computing. Edge computing is nothing but process the data closest to the machines for fast decision. So together, these technologies create the connected and the adaptive production environment for the system making. Okay. So what are the applications generally in manufacturing point of view? It is used for protective maintenance. Because why it is maintenance we are speaking about? Because we have industry will running with very tough production time. So before that they have to complete. So anticipate the failure before they occur, reduce the unplanned downtime. So for that up to by 50%. Next, real time quality control. So inline defect detections using vision systems and AI driven anomaly classification. You may be cross that food industry's maximum will work on this area only. That is vision systems, and nowadays is packaging and other more number of applies. And then we come to the supply chain resilience, because nowadays is all are using Amazon, Flipkart, and Blinkit, and so many of grocery applications are derived. So in that we have to use about what is major role in this. So after that, factory layout and simulation validate the production line virtually before the physical implementation. That is that. These are the main applications. I hope one of the interesting case study here. This is a Formula One car. Maybe you see that the timeline of this is the overall timeline of vehicle system integration. The dozens of engineers will lively virtual the model of car, how fuel is burned, and tire wear and the engine temps. Because it is a spontaneously the action will be happen, and it will cause a major things. So it may run with you maybe see that what is the speed of that one. 287 kilometer per hour up to 3,300 kilometer per hour it will travel. So continuously without of monitoring, they cannot able to change or able to maintain, because we speaking about continuously maintenance because these are the live examples. So when we have farm account, they came to the lab. It will come to the pit. It will happen only to 30 seconds or maximum with a 45 seconds. They have to change everything. If the wheel is totally teared, so they have to rechange, fuel inject, and then they have to arrange the pressure and everything, and then comfort of other equipment in the uh, car, everything they have to check. So initially, this much of the assessment result thing will take the much more role in this. So before going to this, we should know about what is the revolution of industries. So I hope that everyone know that we are in the era of Industry 4.0. So in that we started with the 1760 to 1870 mechanization using the water and the steam. So first we started with the steam power and the water only. So that is coal or boil, steam, piston, connecting rod like this. So this is stage in wheel rotation. This is one of the easiest example converting the thermal energy into useful mechanical work. So like this, all this process happen. What is Industry 4. Industry 1.0 is introduce the mechanization. That is the first initiative. Okay. Second, Industry 2.0. It is the one longest term. 1872, 1969. Mass production using electricity. They introduce the electricity. So what is that? They are given instead of worker moving to the products move to the work like this. And then vehicle assembly time is from you may see the tremendous reduction from 12 hours to 90 minutes and standardize the manufacturing process. Finally, large scale automobile production is possible. That is made by Industry 2.0. Next, Industry 3.0. Most of them in our age people we cross with this scenario. What is that? Industry 4.3.0 is introduce the automation through the electronics and the computer. Okay, that is the best example I keep here. Automotive robotic welding and robots are performed thousands of weld with consistent quality, improve the productivity and the worker safety. What is the benefit of those things? Higher precision, improved repeatability, low production cost, and better quality. So these are the foremost advantages of Industry 3.0. Finally, this is our era, Industry 4.0, from 2011 to here, currently. Smart manufacturing systems. What it means that connected the machines and data, artificial intelligence, and the people. Those are belongs to that. Among the all industries, Industry 4.0 technologies, digital twins are considered the brain of the modern manufacturing. They help the industries to reduce the cost, improve the quality, predict the failures before they occur, and optimize the production in real time. That is the most important. So today, here, how digital twins are work in this area. So digital twin we already represent that it is a virtual representation of physical object, machine, production line, factories, and even an entire manufacturing system. It is continuously receiving real-time information, sensor installed on the physical system. Virtual mode updates itself continuously behaves exactly like the physical object. Instead of waiting the machine to fail, engineers can observe through the digital twin and identify the problem in advance. That is the most important. So, according to the what is the digital twin, as per the uh, National Aeronautics and Space Administration, digital twin is a dynamic virtual representation of physical throughout its life cycle. Understand this? This is the most important throughout its life cycle. If it is a physical machine, it will come to the sensor and then come to the data come to the digital twin and then analyze and give the better decision. So, example, if you take that CNC machine, sensor measure the temperature, vibration, motor speed, tool wear, power consumption. This information is sent to every second to the digital twin. Digital twin predicts that tool wear, tool failure, and bearing wear, motor overheating, product quality. Maintenance can be scheduled before the breakdowns. So this is the way it is improved. So going to this, we can now don't think that it is stopped with Industry 4.0. Now we are going with Industry 5.0. This also slightly introduced in the current trend and it is in progress. Okay, the cobot hold the heavy automotive components while the operator perform the precision assemblies. Digital twin monitor the both machines and production process. and to optimize the safety and efficiency like this, the process. It's and then if you see here, it is a safer workspace, higher productivity, personalize the manufacturing and reduce the AI environment. If we take the evaluation, I given one of the images of all this name Industry 4.02. If we take evaluation of digital twins, in stage one it is called as a computer aided design. Stage one it is a computer aided design and only geometrical models. For example, we can create a 3D model of mission. What is the stage two? Stage two of digital twin is simulation models, testing the product before the manufacturing. Okay, that is called as if you study FEA, there are three methods: analytical, numerical, and then experimental method. So this will come under this method. Next, we have that another process is third stage of the digital twin evaluation is IoT based monitoring. That is a real time sensor. And for the fourth stage of current trend is it is AI driven digital twins. That is what it means that model can learn, model can predict, model can optimize, and model can now recommend the actions. You may be see your all the vehicles, service required, power, battery down, pressure. Now, if you take advanced level of high level of car, maybe see that what is the pressures are less. So these are the things are there. So before once again going to this area, I will touch that what are the this is the initial architect of digital twin. So first we have the physical asset. What is the physical asset? It is the real machines, for example, robots, CNC machines, and then conveyors, pump, turbine. Like this, n number of machines are available. Another one important component in digital twin is sensor. You are aware about it is collect the real time data. There are variety type of sensors are there, but it will connect that analog to digital, digital to analog like this. Basically, the main in terms of in our mechanical term, it is called as a temperature sensor and pressure sensor, vibration sensor, current sensor, position sensor. This is the second component. And another third component is IoT connectivity. If you see here, this is a major role. IoT connectivity. What is IoT connectivity? You know that very well that communication technologies. What is communication technologies? Wi-Fi, Ethernet, 5G, MQTT, and OPTOE. This transmit the data continuously. And then we have the cloud platform. That is a platform. What the cloud platform will do is it stores a large volume of manufacturing data. Cloud platform performs storage and then computing and analytics. And after this, another one, fifth one is called as digital model. Digital model is nothing but virtual motion of machine, virtual model of machine. So that will have the mirror of motion, temperature, wear, and the energy consumption. Now we have that artificial intelligence, failure predictions, and then process optimization, decision making, and then anomaly detection. How does digital twin is work? If you take, we are assuming that workflow is machine operate, sensor collect the data, and then transmit the data transmitted through IoT, and the cloud store the data, AI analyze the data, digital twin updates, and finally it will predict prediction generator and the recommendation sent to the back to the operator. This cycle is continuous for every second. Don't think that it will sense only any fault will happen. It will sense every time. And nowadays, most of the publishing data in this publish in the paper with respect to data alone. That is the beauty in this. So after this, if we take this, we are going with the smart manufacturing ecosystems. So what it means that if we go here, so there are first initially we start with the three-layer architect and then five-layer architect. Now we have connected with a more number of architect layers. Are there. What is a three-layer architect is? One is physical entity and then data representation, data transmission or data processing. Anything will happen. That is a three-layer architect. Now five layers. What is the five layers? Are there? One is service, DT data. DT data is nothing but digital twin data. Okay. After that, physical entity with connection with the virtual equipment. So that will parallelly do with the layers. Next, this is the one of the article is showing that final updation, physical world, machines, product, process, environment. From that, it is collect the data like IoT sensor, actuator, controller, edge devices. It will say give to the digital twin system. It have different layer. First one is if you go with the data acquisition layer, sensor data, and then operation data, and then all quality data and environment data. That data is given to data management. Data management will convert into different area. What are the data management is? One is called as IoT platform and the data integration, and then data storage and data processing and the API integration. Finally, it will come to the virtual twin, 3D modeling and simulation, and before behavior modeling and the process modeling. And after that, what if analysis is going to do? Analytics, and the AI layer is given the data analytics, machine learning, predictive analytics, and optimization, and the prospective insights. So that will give the enabling technologies. What are the technologies we use in this? Cloud computing, edge computing, IoT, 5G connectivity, big data technologies, cyber security, AR VR integration, blockchain. We have in our college we have AR VR lab. So in that nearly 1.2 course we are spent for integration establishing the AR VR lab. All departments are using with the interdisciplinary they are creating. What are the business dashboards users can see that insights? So dashboards and visualization, real-time monitoring, alerts and notification, decision support, and analytics, remote access, and outcomes of real-time visibilities, predictive maintenance, and another one. So if you see here, in case study of BMW, okay, one of the BMW, I hope that mechanical engineer, those who are studying the mechanical engineer, we are very passionate and we are very interested to maybe we get sorry we need to get opportunity to join BMW. So in BMW group of companies are introduced that one here you maybe see that how they are using the digital manufacturing. So that is the digital manufacturing. So how they are using the digital manufacturing. One of the video I am showing to you. Okay, some of them told that audio is not visible, right? Audio is being picture. So what this company is BMW is showing that they are showing the plant of you see here in this particular this area. They need to incorporate the another robot instead of this. I hope you all visible this thing. This is one of the layout. The cell they have to change this one. So now the industries are or any other plant they are virtually represent. So instead of this cell they changed here. You see here they are changing the places. So they moved this robot to that side and they are removed this one and they are adding the another robot instead of that yes places. So like this virtually factories are nowadays is represented. So, okay. So this is one of the interesting. In next video I try to make a sound. Next we are going to see that this is the first case study. If people are what why I'm showing this video is if people are aware about those things. It is not mean that it is only for any for wording they are saying that or catchy words, digital twin or digital something like that. The industries are implementing the all the key points. So I already told that a production new area line is required, expensive physical prototype, long installation